Hello and welcome. We are going to start our next session with Mary Grygielski, developer advocate from IBM. Hello, Mary.
Hello, Thomas. So good to see you.
Yes, yes, yourself. So Mary will be talking about a very interesting question. I'll be trying to answer a very interesting question that we also received before the conference. Is microservices the silver bullet? So should we use it everywhere? So Mary, handing over to you. Could you please share your screen and we can start your presentation?
Yeah, sure. Hold on a second. It's been a bit of a crazy thing with my machine, but I'm sharing my screen now. So, okay.
Yes.
Okay, share screen. Somehow I think because I'm having issues with my computer, so it needs my security set up. So give me a second. I'm so sorry.
Yeah, no worries. Okay.
All these things. And then it needs my password. I am very sorry. It's kind of amazing, right? We're doing so many things all the time. Wait. And then if something doesn't go right, and then that's what happens. So I just have to give permission, and will not be able to record. Okay. Oh wait, it needs me to exit this and then comes back. And so if you don't mind, I'm going to quickly exit and then come back. I have to basically close the Chrome and then come back.
Sure. Yeah, okay. No worries, okay. Mary. We'll be waiting for you.
Okay, thank you.
Yeah,
sure. For a few seconds. Okay. All right.
So we are waiting for Mary to reboot the computer, and we will start our last talk for today, planned for today. Just one remark: if you would like to ask any question to Mary or to any other speakers that presented before, please use your chat screen on the YouTube channel, and we will ask these questions after Mary's presentation. Also, if you would like to ask any questions after the presentation, just drop us a message at info@scalac.io, or you can find us on Twitter, and we can handle any questions. And also, if there will be need any help from Mary, we can follow up with Mary. So, are we ready to start? Yes.
Finally,
okay.
Got things set up.
Your presentation.
Good things come at last. So I promise a good show. So thank you. Thanks for your patience. So.
Yeah. No worries. It's always a pleasure to have you, and especially to see your presentation. Yeah. So handing over to you, Mary.
Thank you, Thomas. Thank you, everybody. Welcome to my talk. Again, thank you so much for your patience with me. There's been having some machine issue and all kinds of stuff. But so thank you. Right now, we're almost summertime here too in Chicago, and that's where I'm based at. So lots of things happening, and I'm sure too it's beautiful in Poland. I wanted to come, so when I can travel, I would definitely visit. So, okay, but back to serious business. We're here today. My talk is about really questioning, right? Is microservices the silver bullet? Is it a cure-all? Does it solve all the problems? It's got some noble ideas in here. So I'm gonna explore this topic, right, within the next 25 minutes or so. And okay, give me some patience. Let me kind of advance my screen. First of all, who am I? Who is Mary Grygielski? I have a Polish name, actually, as you all know. It's because of family. And anyway, but I love it. And so I'm familiar, with a lot of things in Poland. And I just, like I said, I love visiting your country. Anyway, so I'm a developer advocate, senior developer advocate at IBM, primarily in the Java, open source, cloud, and DevOps space. That's what I do. And also, too, I have heavy interest in enterprise distributed systems. So that's my area. focus. And currently I'm with the WebSphere engineering team. So my project areas are all open source Java related products, OpenLiberty, MicroProfile, and Jakarta EE that are perfect for doing microservices development in the cloud native time period that we are in. And outside of work too, I'm also very active with the technical community. I'm a president of the Chicago Java Users Group. We are 3,100 and more members these days. We're running online meetups in the pandemic time. So if you'd like to join, please, by all means, join us too. And I have over 25 years of software engineering and architecture experience in various capacities, product development, and also applications too. So I've done applications in the enterprise world. So I kind of bring a unique perspective too. I've done product, which is kind of slightly different than applications. You're really in the trenches, so to speak, right? And helping to deliver software. So I fully understand, right, the challenges that's kind of we face every day. So, okay, so with that, let me start. First of all, let's ask too, and I'm sure you already have heard of microservices, but let me kind of make sure we're all on the same page. So what is microservices? So I kind of look up, right? Everybody look up at Wikipedia. It's essentially, right, it's an architectural style. It's a variant of the service-oriented architecture, SOA, structural style. It arranges an application as a collection of loosely coupled services. So that's like the core of it, is a loosely coupled thing. And in a microservices architecture too, services are very fine-grained and the protocols are lightweight. Excuse me. So it's essentially too, if you look at this picture, right, it's like all of these, specific service, right? That's what it is. It's basically usually, right, we use RESTful kind of exposure for connection. So in this case too, they are independent. They have their own database. They manage their own resources. Everything's very independent. So that's why I highlighted the loosely coupled kind of aspect of microservices. But let's kind of get into a bit of history behind microservices. As some of you too may have kind of worked through, right, through history, how did we arrive at where we are today with microservices? So before there were microservices, there were SOA, service-oriented architecture. And then also enterprise service bus, the ESB. So ESB isn't necessarily the only way of doing service-oriented architecture. You can have others, but the thing is, the primary kind of driver of that was actually the enterprise service bus. So I myself actually have worked on the Oracle Enterprise Service Bus ESB for their Oracle Service Bus product OSB. So I'm familiar too with SOA, and I can also understand the pain too of SOA. It's not so much like it's bad. It's just that it cannot like grow, with the times, with today's world, cloud native kind of era, right? So that's where we are in. Okay, so before SOA, then what was it? It was actually monolith, right? Everybody's heard of the word monolith, and I specifically use a dinosaur to indicate that, right? But it's sort of more like, okay, everything's as encapsulated into like one like giant kind of a service, right? Now, for me, I come from Java background, so it's more like the VM, the virtual machine, that kind of essentially encapsulate all of the services within the same JVM. So there are obviously like, challenges too. So let's take a look. Challenges of the monolith. Large code base, right? We tend to have many business modules, especially for like serious, like enterprise computer systems. So say, for example, I worked at the Chicago Mercantile Exchange. So as you know, right, futures, options, financial exchanges are very hard, fast-paced, and a lot of information, all the trade information, trade subscribers, traders, and all that. So the thing is that we have like separate, systems, right, for employee, and then there are customers, there are subscribers, there are partners, there are like little trading firms that partnering with that, all these things, right? So a huge code base to manage just the resources, people aspect, companies and entities, and not only that, then the trading aspect, and not only that, right, on top of that, regulatory, all these like important things to kind of keep the exchange running. All these things is huge. The code base was actually very huge, and in fact there were like separate systems for even doing clearing, right, to clear all the trades, and it almost seems like a separate company. So all these things, right? It's huge. If you do everything monolith, then guess what? I'm sure we all play the game three-legged race, right? And when you have to like partner with someone, you tie your legs together and then you try to run, right? So I kind of think of monoliths. If you every time you do any kind of upgrades or just small updates, you have to make sure everybody is in sync before you can do anything. So that's kind of like a challenges of that. However, think of the good things though, as compared with today's microservices, is that like if you have everything all together, well, guess what? From a programming perspective, in some ways it's less kind of complicated in the sense that because you do not need to necessarily communicate with another process outside of it, right? There's not much to worry about the network, the latency, that kind of aspect. So there's some pluses too, but then the times have changed. We're in a cloud native era. Everything has to be fast and quick. Containers, all these things. So the monolith really cannot handle the pace that are going. So okay, so if you think of it, right, even like deployment aspect, right? I remember myself, right, doing deployment. Oh my, you need to deploy the order. Let's say the order aspect, right? You essentially have to have all of the other components all like wait, in a wait state and stop because they have so much like tightly coupled dependencies. The integration, kind of like interface are like not very clear. Everything is really tied together. Think of it like Lego's pieces. Instead of Lego, you get the pieces all glued together. So it's very hard. You want to deploy, it's hard, And then if we're doing work myself in development and all of a sudden QA says, well, it doesn't work, they report problems, and your development wants to replicate, kind of they reproduce the error using the same environment is close to almost impossible sometimes. And then if you want to do it, it will take, a lot of, time to do that. So this is very expensive, right? And so now if you think about it, right, there's also scalability aspect, right? Systems grows, you need to have more customers now, all that stuff. You want to scale it is also a nightmare. You want, all the intermodule dependencies, I already talked about upgraded hard. So now then let's move on, right, to SOA. SOA benefits is really like over the monolith is really the reusability. It encourages reusability. And I also talk about, right, the enterprise service bus. So you have like a single kind of communication kind of a channel that channels all these services and services, all of them. So it seems like good, right? And then there's also stateless services, right? You can use HTTP. All that stuff, it's quicker. No doubt it's quicker and everything. And there's interoperability too. In fact, SOA kind of works quite well in the sense that you can use different protocols. Now, if you have worked with it, that's the web services description language, where you kind of describe all of your interface very clearly. So you can also have different toolings, different languages to implement different parts of your system. At different, clients, you can have like a JavaScript client talking to an Oracle, enterprise Oracle, service bus SOA using SOAP, right? And then the simple object, simple object access protocol, right? So SOAP protocol actually is over as HTTP, all these things. And then you can, again, the WSDL, right? WSDL, the web services definition language, contract based, and it just all seems good, right? And you can scale it. Okay, that's okay. We can scale it too. We can handle it too, right? If you're like running Oracle at the time I did, was like you kind of just follow the instruction, do all the clustering, the load balancing, all that. Yeah, so life seemed to be good for a while. And you try to upgrade, you can upgrade easily. But it falls short, on the communication. You're depending on the ESB, right? The single point of failure. If that fails, everything fails. And service granularity too. You can range, the services too. You can certainly kind of do it like the microservices style. Nothing's stopping you. Small things, small services and all that. But then there's sometimes though, in a complicated enterprise environment, you have complicated things to deal with, right? So your services can also be very big. And I recall some of these, right? Especially when you're dealing with some sort of like order processing. It gets quite complicated, right? And has to link into shipping, link into, well, not only that, before that, payment and all those things. It gets kind of complicated. It's less granular. And the speed too. Actually, the thing is too, they operate slower too, because it favors, right, the starting of resources. Now, that's the thing with SOA, you share all the resources. You have maybe like one or two copies. I mean, the database itself can be replicated, but each one, well, kind of, I should say, all the services access the same database essentially. So the thing is, it can be slower. You can have bottleneck, right? If you don't have enough connection pools and things like that, if you don't tune it right, it's got issue. And also, too, let's then kind of move on to microservices today, to today's world, but some historical tidbits, right? So the term microservices was kind of first kind of used, it was back in the mid 2011 at a workshop of software architects. And from ThoughtWorks, we have James Lewis, the architect leader, and he presented the first talk about his idea about microservices back in 2012 in March. And by the end of 2013, that generated enough interest, right, in the whole IT industry that they start talking about microservices. So what it is, right? So finally, in 2014, Martin Fowler, the kind of leading expert, right, from ThoughtWorks, with James Lewis, they both did their first talk, like official. So essentially, microservices architectural style is an approach to developing a single application as a suite of small services, right? Each running in its own process and communicating with lightweight mechanism, often HTTP resources API. And these services are built around business capabilities and independently deployable by fully automated deployment machinery. There's a bare minimum of centralized management, and that's kind of like the key. There's not centralized of these services, right? So supposedly make it easier if you're decentralized. And you can write that in different languages and different flavors of things. So essentially, it doesn't dictate what you need to use to implement it. It's just a style that you must follow. So all is good. Now, in today's world, cloud native and microservices. Okay, a match made in heaven. It sounds like good, right? So let's take a look, right? I'm gonna kind of describe a bit of cloud native, especially if you are still contemplating about doing things in the cloud native way. But I'm guessing a lot of maybe companies are already considering or already doing it too, maybe quite advanced too. But still, this is an area that's kind of growing. Is essentially cloud native is an extension. To me, in my mind, I think of it more extending the cloud computing capability. Because in the 2010s, right, when cloud first came out, it was mostly about cloud infrastructure, Kubernetes, containers, all of these. They do their work well, but they never really get themselves into application. But the thing is, though, in all kinds of business, the application is the key, right? It is the main kind of driving kind of important things to keep your business running, keep the world running, everything. So that's actually very important. So cloud native is essentially you leverage on the cloud computing infrastructure and extending the cloud for enterprise, especially for the enterprise business operational type of systems, highly distributed like that. So, okay, so then let's take a look, right? How do we do cloud native development? It's essentially also cloud native is like an overarching approach to it, covers everything. If you think about it, it covers like development in the cloud infrastructure, which means like everything. Okay, so I kind of quickly kind of copy over these 12 factors. There have been also talks about 15 factors now. There are additional factors, but Heroku, right, the company that they do also they host systems too, right? They host like cloud systems, cloud native systems. So they come up, right? The developers came up with this 12 factor. It's a guidelines for doing cloud native. So as you can see, I won't go over every single thing, but just pointing out too, right? From the code base, right? You must have your code in the code base that are versioned and everything, so you can kind of go back and trace back if there's something goes wrong, you need to roll back. And then there are also like dependencies. When we run systems, it's not just the system itself. There are lots of inner workings, so it manages all of these things, configurations. The backing services, logging. Okay, so one important aspect, DevOps, right? DevOps, it helps with actually enabling the whole cloud native the systems to be very efficient, right? The code comes in, you want to do an quick like continuous build, continuous integration, and then as a result, continuous integration and then deployment, right? Make it ready right away. So the whole cycle is real fast. So I highlighted to number 6, it specifies processes, right? Processes basically is you want to execute the app as one or more stateless processes. So stateless is the key. Stateless is there's no need for you to worry about keeping track of the data. Everything you do, just do it. Think of something like no memory, just go do it. Very agile. So that actually microservices architecture fits very well into the cloud native kind of specification, or kind of like the guidelines. So now if you continue looking, there are also port binding, the concurrency, all these things, but there's also the disposability. It means that you want to make sure that your service can not only, can execute, but it starts up fast and also has graceful, quick shutdown. So that also microservices conforms to, the standard kind of specification in, the guidelines in this 12 factor. So as you can see, microservices and cloud natives are kind of perfect, right? And then there are other aspects to the logging, the admin, all these things. You want to essentially decouple all of these different kind of aspects of your whole system. So it covers everything. Okay, so now then kind of comes into question, right? Back to my original question of this talk is microservices the silver bullet? And the answer is that it really isn't. It isn't a cure all kind of solution. Now, but that's the thing, is not like to say, okay, don't do it. That's not what I meant. It's more like, let's examine what it really is, get a really good understanding, and basically use the right tools, the right approach for the right job. I think that's the attitude we should always have, right? It's not just like, okay, it's hot, let's do it. But it's more like, well, let's see what we have. We go and examine our business processes, what it is, and what is it that we're doing. Are we like into e-commerce, right? Or dealing with other things. For example, like telescope. I'm involved with a project actually doing telescope, right? Kind of astronomy, kind of collecting data, right? IoT and all that. So they're different tools for different purposes. So we need to always like look at our business processes and take a look and see if it's, are we using the right tool for the right job? So, okay, but back to microservices. So the idea is that this loosely coupled decentralization. So the question is it really so? So I'd say no. Let's go. Okay, so first of all, let's kind of consider, right? So now what used to be, right, like a one system, then we have all the components all together. It's easier and to do things. But now, breaking it up, and of course, they all run in their own space. Not only that, too, right? In a cloud native environment, you got services that are replicated, let's say Kubernetes, right, on the different pods. Different pods can sit on different, persistent storage, right? All of these storage, and they can be logically the same, but they are on different, physical systems. And sometimes, a lot of times too, especially if you want, with Kubernetes, it also has a lot of replication, for high availability, kind of disaster recovery. You replicate all of stuff all over the world and everything. And the thing is too, with cloud native, with Kubernetes, it keeps the state of all of your pods conforming to the spec. So at any point in time, if a pod goes down, it will generate a new pod for you, that type of stuff. So it has all these like functionality. However, nothing can happen without the network, right? So now there's this kind of idea of network fallacy, right? So basically the fallacy of distributed systems is noble and grand. But we're kind of like assuming, that we're believing that the network is secure. That's one thing. And also the network kind of stays up all the time. So that's the thing, right? That's this aspect. And not to say we don't do anything. That's not what I meant. But it's more like, okay, with that in mind, then we want to make sure that in any point in time too, when you do microservices, especially in a containerized kind of approach, especially in a cloud environment, you get charged, by the minute, by the seconds, right? Sometimes. And so the thing is too, you also want to make sure that your microservices are very slim. There are no additional burden that's kind of you need to carry around with your microservices, very precise, basically. Because what is happening is that in the container world, you have these servers, but your servers are hosting, like they're multi-tenancy, right? You're hosting many versions of or actually not versions, instances of your containerized microservices. So you want to make sure each one of them use just the right amount of resources. If it's not, processing anything, it needs to kind of be idle and not be charging your money. So that's very important, right? And all these things. So, okay, so back to that is that there's network latency too, right? That can also easily add up too if your number of microservices is very high. And actually, one thing I wanted to point out too And that's something that that I recently started chatting with the Java performance expert, Kirk Pepperdine. He's with Microsoft now. He's kind of the authority on Java performance too, JVM performance, right, among the few who are very good. So he was just kind of commenting to me that they've done a research on testing microservices. And believe me, the thing is that what they have found out was that it's really the thread scheduler that is the bottleneck, right? You can kind of, a lot of times if we say that, okay, there's network issue and all these things, and we can increase memory and all those things. But the thing is that the unit of work has to be very precise too. So then you don't kind of do extra things. And so how you design your microservices is also very important. You want to make sure that the size of it is important, and there's also the thread scheduler, because every time, right, we think, oh, we're doing microservices, but underneath the hood, on the lower kind of computer kind of infrastructure layer is really the threads that are like sending out all the work to to kind of say that it's your turn to execute all these things, but it's really the scheduler that's kind of controlling all of these. So you have to make sure that that's kind of like the essential kind of driving thing to kind of make your microservices be executing. So you do want to make sure your microservices are designed very well. And also then keep in mind, right, there's network fallacy and all these things too in mind. And so that's something I think it's very important too. So, okay, another aspect of it too, I'll be cognizant of the time, I kind of tend to like to talk. So, okay, then another thing is that there's also business transactions. So that's a talk that I recently started talking, right? So don't forget too, we are dealing with a stateful world, we're dealing with business transactions, e-commerce, right? How often do you hear to customers, they are in your e-commerce system, you're trying to order stuff, and because it's the complicated thing, right? You're doing ordering, and then at the same time, you are checking to see if your catalog inventory system has the merchandise that the customers want to buy and all those things. So all these processings are happening. They have transactions too. So you want to make sure that data consistency is very important. Let's say you want to place an order, and then you go to the next microservices, you place the order. Okay, well, the order is being put on hold. So all of the other things too will be doing their checking, checking your credit card, checking your inventory. All these things are happening. In the meantime, the order is being kind of put in, kind of like a waiting state, right? All these kind of orchestration too is very complicated, right? And the thing is, so that's another thing. In a cloud native world, right, we're talking about stateless. So, and then the question might be like, what are we talking about? We're doing containers. We mean to be fast, but our real businesses, we need to deal with real stuff that we need to maintain the state that actually goes against the principle of stateless. Now, I have another talk that talk more about how do you do stateful, right, to maintain the statefulness. So that's important to know too, not just like doing microservices. We got to take care of business. We want to make sure that especially some business transactions can span days. Maybe you are like doing some ordering, you are like putting the order on hold and things like that. So you want to make sure that there are all the facilities in your entire system be able to keep track of this transaction so that it doesn't get lost. If your server often lost power, things like that, right? You have somewhere where you can back up and make sure you save all of these transactions that are still being, kind of like in the middle, right? Kind of in a suspension, well, not just suspension state, but it's more like in a wait state, for the next transaction, next action to do. So all that kind of stuff, is not as simple as it looks, but there are obviously kind of toolings out there to help you do it too. So, okay, so that's something we need to get in mind. Now, for me too, well, because I don't have as much time, so I just want to also point out this very important thing is actually technology is important to kind of make sure it can do its job. But the cultural change too is of equal importance too in your migration towards more of a microservices, cloud native changes. You want to, because now you're breaking down, all of your operational details, implement them in different services. So then it will naturally involve the people who are working on it. There are different departments. You have order department, purchasing department, shipping department, the credit card, all these things. So you want to make sure, ultimately, to make sure everybody has to work kind of peacefully together. Now, if one my order department, the people doing that work, they're not willing to kind of work with the people in the inventory, then you'll be in trouble. And then if you kind of publish certain interfaces, right, APIs, and then if the other department said, no, we want to do things this way and that way, you end up arguing, and then, nothing would get done. So it's ultimately important too, alongside with your technology, you do need to have the organization to be ready. You need to have management supporting these changes, and also understand too, right? The developers also under big, kind of a pressure too. They are also maintaining existing systems, but they also have to take care of new things, right? So kind of make sure that these are all being addressed too, not just like doing the work. We're living in a giant, very complicated world. However, if you make this fun, right? This can be fun. You're trying to do distributed systems, and everybody doing things in a new way. I think that's what it is, right? And instill a sense of like, kind of this is like fun thing. We're making things better. It will be better in the future. I think that would be really great and make everybody work together. So. Okay, so I think my time is up. Yeah, I think I'm supposed to be only, and I started late, so I'm kind of a little bit late. But I do want to share with you some resources. It's a bit more of a technical side, but at IBM, because I'm come from a technology development, advocacy. So I'd like to just point out to you too, right? At IBM, we have microservices. If you want to learn more about it, we have solutions that we offer to you too in your suite of products that you're considering. And of course, there's also SOA that I talked about, right? We have IBM Cloud Education that also gives you information on that. And then there are also industry information. I mentioned about Martin Fowler, James Lewis from ThoughtWorks. There are links to all the microservices. And Chris Richardson, based in California, and he has great things on microservices.io, that site, design patterns. And myself too, I work with Open Liberty, Microprofile, and Jakarta EE. These are all conforming to the Java EE spec. So if you need more information, please reach out to me. And how to reach out to me, these are like the various ways. Follow me on Twitter, my LinkedIn profile, and also my Discord server if you want to continue with the technical discussion. So, and that's all I have for today. I hope it's kind of helpful and kind of help you to, as you navigate right through this complicated maze. So yeah, thank you, Thomas. Thank you so much. Yeah.
Thank you very much, Mary. Thank you for your talk and being with us. I really appreciate this. And so thank you. Thank you very much.
Thank you.
I'm checking if we have any questions to Mary.
Sure.
Maybe one question from my side, because you mentioned at the last slides about the structure, or maybe the question is, do you think that team structure is an important success factor in implementing microservices architecture?
Okay. If I understand your question, you're saying that like a thin structure, you're saying?
No, a team structure. So
team structure. Yeah.
Yeah.
That's right. Exactly. I think that's what I thought too, right? I was kind of talking about the cultural change is really inevitable. It is very true. Like I said, I also was actually in a cell phone company before, in which we were starting to break things down into microservices. So we have different teams that actually work alongside, like the development, right? We work alongside with the business functional side too. And we found it to be most kind of productive, because then we kind of get the people doing the work and then talking with the business people, the stakeholders together. So that kind of structure, it seemed to have gone well. It is my experience too. But of course, different companies have different culture. So you may want to experiment with that, and also kind of get everybody the mindset. I really kind of can't emphasize enough about the need to get everybody's mindset to be ready. There will be change, but the change is good. I think that's what I feel is very necessary, and it can be fun. And that's the kind of sense you want to create in people, and kind of rally the troops, get them excited and do things in a new way. So yeah, that's what I think. So.
Thank you, Mary.
Thank you, Thomas.
We have one question, as I see. Let me read it. So the question is ASB in software in SOA fulfilling same role as service mesh in microservices?
Oh yeah, good question too. SOA, they do too. ESB, I think from a business perspective, it does solve the business problem. However, in the cloud environment, cloud native type of newer infrastructure, right? Dealing with cloud containers, I feel I haven't actually done any SOA and then deployed to the cloud. I'm not even sure, right? Cloud native. But I think the thing with microservices is definitely the architecture to use if you are kind of moving to more of a cloud native way of implementing your whole infrastructure and your whole application. Because again, SOA, ESP, right? The ESP is kind of like the central bus. So you still kind of have a bit more of a kind of a tight integration between all your services have to go through the bus. And so it can be, it can be efficient, but at the same time, if the bus ESP goes down, then you're kind of in trouble, kind of thing. So yeah. And then that's my kind of opinion on that. So yeah. And somebody asked a question. I'm sorry. Yeah.
Yeah, is there any other question to Mary? No more questions. Okay. Hope to have you, Mary, on site next time in Poland.
Yes. Yeah, I would love to. Yeah.
Hope that
Thank you.
It will be possible. So so thank you very much, Mary. Mary was our last speaker. And I would like to thank you to all of our speakers. It was, I guess, a lot of stuff about microservices from different angle, from helicopter view, from security, from the startup point of view. So I guess that there will be a lot of good content to discuss. We are always happy to answer any questions that pop up even after the meeting. Just please visit Scalac.io or just send us info send us email at the info@scalac.io. All recordings are already recorded. All talks are recorded, so you should expect that there will be available soon. On our YouTube channel. Also, please follow up us at Scalac.io, and we are trying to deliver the best content. Thank you so much to Maya and Jacek at Scalac. And so it was great to have such a great team. And so that's almost all for today. Thank you very much. See you on the next episode. And yes, we had planned one more speaker from Splunk. Unfortunately, he didn't manage to join us, but I hope that we will record this meeting and will be available on our website or YouTube channel soon. So thank you very much once more to all participants, and see you again. Bye-bye.